This is a GCSE chemistry tutorial within topic 9. In this video we're going to look over the evolution of the atmosphere. In this tutorial we will look at the Earth's early atmosphere, we'll look at the role that water vapour played, we will look at what happened to the high levels of carbon dioxide, we will look at how oxygen levels increased, focusing on photosynthesis, and finally we will look over the Earth's atmosphere today. Within this tutorial, we will look at the main gases that make up the atmosphere. We will compare our atmosphere today with that found in the early atmosphere, and we'll look at how the atmosphere has changed over time. Being able to describe how the Earth's atmosphere has changed over time is the big question for this tutorial. The Earth is surrounded by layers of gas. This is what makes up our atmosphere. Our atmosphere can be divided into lots of different sections. This is near the surface, and then as we go out we get different layers. Without the atmosphere, the Earth would be completely uninhabitable. It would be incredibly cold, and we'd be exposed to the sun's radiation, and we wouldn't have any oxygen to breathe. As you will look at in one of the triple units for physics, different planets also have different atmospheres. Venus's, for example, is much thicker than ours and would be incredibly hot. Mars has a much thinner atmosphere than us. So what was the Earth's early atmosphere like? Well, the Earth was very hot and had lots of volcanic activity. This meant that it contained lots of water vapour. As the temperature was incredibly high, all of the water had evaporated and was existing as steam in the atmosphere. We would have had very high levels of carbon dioxide and very high levels of sulfur dioxide. That sulfur dioxide would have been released from the volcanoes. Volcanoes would have also released some nitrogen, so there would have been some nitrogen, argon and hydrogen present. There would have also been small amounts of both methane and ammonia. So how did our atmosphere change over time to the atmosphere that we have today? First, we're going to look at the water. So what exactly happened to it? Well, over time, as we got less and less volcanic eruptions, the atmosphere started to cool. The Earth itself started to cool down. As it did so, the water vapour in the atmosphere condensed and it formed the oceans that we have now today. Carbon dioxide, or CO2, was another gas that was very common in the Earth's early atmosphere. Today, only about 0.03% of the atmosphere is made up of carbon dioxide. So what exactly happened to it? Well, a lot of carbon dioxide was removed from the atmosphere as it dissolved into the oceans. The dissolved carbon dioxide went through a series of reactions to form carbonate precipitates that then formed sediments on the seabed. Some marine animals were then able to use these carbonates to form their shells and skeletons. A large amount of carbon dioxide was then converted into oxygen by green plants and algae, which evolved later on. These were able to carry out photosynthesis, which we will look at in more detail in a couple of slides' time. As these organisms died, some of the carbon they'd taken in from the atmosphere and the ocean became locked up, either in rocks or in fossil fuels. When plants, plankton or marine animals die, they often fall to the seabed and get buried under layers of sediment. Over millions of years, they then become compressed and form sedimentary rocks, oil and gas. This traps the carbon within them and helps to keep carbon dioxide levels low. This is how fossil fuels are made, so this includes coal, crude oil and natural gas. Crude oil and natural gas are formed from the deposits of plankton and marine creatures. Coal is a sedimentary rock made from plant deposits, and finally limestone is a good example of a sedimentary rock. Limestone is predominantly calcium carbonate and is made from the shells and skeletons of marine creatures. The final part of the puzzle for looking at how our atmosphere is the way it is today is the increase in the amount of oxygen. as we discussed earlier, oxygen really starts to appear after the evolution of organisms that could carry out photosynthesis. Initially, this was done by algae that evolved about 2.7 billion years ago. Over the next billion years or so, green plants then evolved to carry out photosynthesis as well. You will have come across photosynthesis in biology as well. The word equation for photosynthesis is carbon dioxide and water goes to glucose and oxygen. This is an endothermic reaction as it takes in energy, this time in the form of light energy. The balanced symbol equation is 6CO2 plus 6H2O goes to C6H12O6 plus 6O2. This huge increase in the amount of oxygen in the atmosphere over time allowed more complex life, for example animals, to evolve on land. Eventually, about 200 million years ago, the atmosphere reached a level at which it is very similar to today, so a very, very similar makeup. This means that our atmosphere is pretty much the same that it was 200 million years ago. It contains nitrogen, oxygen, argon, carbon dioxide and water vapour, which leads us on to a very important pie chart. The atmosphere today has 78% nitrogen, 20.9% oxygen, just under 1%, 0.9% of argon, 0.17% of other gases known as the trace gases. These are things like water vapour and hydrogen, and finally 0.03% of carbon dioxide. Although this percentage of carbon dioxide is increasing, as we will look at in the next tutorial video.